All right, hey guys. Gonna put up today the video for the 2016 non-calculator free response questions that I put up earlier this week. So these are gonna be the solutions to those. Um, all right, so let's go ahead and get this thing moving. There are two AB questions in here and two BC questions. So the first one is an AB level question. And it goes like this. So there's a figure above. There's a graph of this function f. So this is f. All right. And the function g is defined by this integral. All right. So there's g. G is the integral from 2 to x of f of t dt. And then the first thing they ask me is, does g, not f, does g have a relative minimum, relative maximum, or neither at x equals 10? Well, the thing we have to ask ourselves is, how do we determine whether or not something has a minimum or a maximum? And to do that, we have to think about its derivative. So things have relative maximums or minimums when their derivative is equal to 0. So g prime of x, if I take the derivative of this, I would get f of x. So what I want to find out is, when is g prime of x equaling f of x 0? And is that true at 10? So I guess maybe more accurately, instead of finding when is this true, is it true at 10? So g prime at 10, which is f of 10, is in fact 0. So that's good. We know it has the possibility now of being a minimum or a maximum. The next thing we need to do is we need to see if g prime changes signs. So basically, does f change signs from positive to negative or negative to positive at 10? And since f of x is less than 0 on either uh, um, on either side of 10, g does not have a min or a max at x is equal to 10. Basically, the only way we would have a max or a min is if f changed signs on either side of x equals 10. Next question they're asking is, does g have a point of inflection? So now they're going, instead of talking about g prime, now I start worrying about g double prime. G double prime would be f prime of x. So what they want to know is, does f prime of x change at 4? So here's 4, and first we had a slope that's increasing, then we have a slope that's decreasing, and so we say yes, g has a point of inflection at as x is equal to 4, because f, the graph of f, changes from increasing to decreasing at 4. Okay, third question they ask me. They say, can I find the absolute minimum value and the absolute maximum value of g on the interval? So not where are these things located, what are the actual values of their maxes and mins? So you have to think about, what are the places that might be an absolute max or an absolute min? Well, 2, -4, 6, and 12. These are all places where I might have a max or a min. I should also consider 2 just to be sure, because that's where I start. Alright, so we want to put all those places in. So basically what I want to do is, I would like to find out what the value of g is at all those various places. So I'm going to have an x, and I'm going to have a g of x, kind of a table here. And in that table, remember, we're going to have -4, -2, 2, 6, and I think 12. All right, well, I know g is 0 when x is equal to 2. And basically, I know to get to these various values, I'm finding the areas of these triangles. The good news is it's pretty easy things to find. So let's just go to 6, for example. That's the integral from 2 to 6 of f of x dx. And that integral here is a base of 4, height of 4. So we're talking about that is a value of 8. So 8. To get to 12, oh, and it's negative, excuse me, because we're above the axis. Okay, yeah. Whoops, not negative. We were positive. Wanted to undo what I'd done. All right, now let's talk about going to 12, from 2 to 12, f of x dx. Well, this triangle and this triangle are equal, so to go from 2 to 10 gets me back to 0. But then I'm going to keep going, and I have another triangle here, height of 4, base of 2. So this is going to give me a value of negative 4. Now we need to go the opposite direction. The integral from 2 to negative 2. Remember that that's the same as going negative the integral from negative 2 to 2. I think a lot of you, if you don't flip that around and change it to a negative, you're going to get the opposite sign here. So I want to find this area, and then I want to change its sign. So this is a width of 4, height of 4. So this is 8, but it's going to be negative 8 thanks to the change in sign. And then lastly, we're going to go from 2 to negative 4. Same thing, we're going to flip it around. And in that case, we're going to bring back 4 of this, and it's going to go to negative 4. All right, so I've checked all the places. My absolute, I'm going to say G, has an absolute max of 8 at x is equal to 6 on negative 4 to 12. And G has an absolute min of negative 8 at x is equal to negative 2 on negative 4 to 12. And I write it in this way because this is the part that's telling them the value. This is where it happens. And if I got confused on the AP exam and I couldn't remember which thing they were asking me, by writing it in this way, I've kind of guaranteed my answer. I also made sure to clarify what exactly is having the absolute max and absolute min, and on what interval that thing occurs. I want to make sure that I'm being very specific about what it is that I'm finding, what are the conditions under where it was found, and what the answers are. Okay, D part. Find all the intervals where G is negative. Okay, so we see we have some places that G is negative. You can see over here G is negative. You can see here G is negative. So to do that, I kind of have to find out where is it 0. What I notice is when I was doing this interval, this is all, remember this opposite going backwards. That was negative area, negative, negative, and then this became positive, but all combined it was still negative. So basically I already know that from negative 4 to 2, I know I'm negative, but I also have a place after that where I've got to get negative. And you remember, this plus this was 0, and then everything after that was negative, so also from 10 to 12 must also be negative. Okay, let's go to the next problem. Sorry, my cat's being a little strange. I'm going to see if we can show you. She's just kind of sitting here staring at the wall, not doing anything. It was very distracting. All right. Okay, so let's see. Moving forward. Considering this differential equation here, x squared minus 1/2 y. By the way, this is a BC question. You're going to see y at the end. Then we define the second derivative of this in terms of both x and y. So d squared y over dx squared, we're taking the derivative with respect to x. We'll get 2x minus 1/2 dy dx. I can't leave it like that. They say they want it in terms of just x and y. So this is 2x minus 1/2 times x squared minus 1/2 y. All right, that part was an A-B level question, so that part alone was not all that crazy. Let's get to the second problem. Let this thing be a particular solution whose graph passes through this equation, negative 2, 8. Do we have a relative min, a relative max, or neither there? Well, to figure that out, I need to use either the first derivative test or the second derivative test to be able to determine a relative min or a relative max. Those are the two things I have available to me. So the first thing I'm going to check is dy dx at 2, 8. I got to make sure that's 0, because if it's not 0, then I'm not going to have a relative min or a relative max. We saw that in the last problem. So if I put 2 in for x and I put 8 in for y, then we end up with 0. So we got a chance. The way the first derivative test works is we would then need to know what happens around it, right? Is the derivative, are we increasing or decreasing to the left, and are we increasing or decreasing to the right? But this is a function of two variables, so I don't really have that as an available option. But what I can do is use the second derivative test. The second derivative test looks at concavity to determine whether or not we have a relative max or relative min. So what it looks at is the second derivative, which I just found. So the second derivative at 2, 8 would be equal to 4 minus 1/2 times 4 minus, put in that thing, and you get 4, and you get 4 as my answer. So what that tells me is that that's greater than 0. And since I have a first derivative of 0 and a second derivative of greater than 0, I can say since dy dx at 2, 4 is equal to 0 and d squared y over dx squared is greater than 0 at 2, 4, then I know that this thing is concave up. That lets me know that f has a relative min at 2, 4. Or excuse me, negative 2, 8. These were all negative 2, 8s. Okay, let's go to the next one. Let g of x be the particular solution given to this equation, and they give you a little initial condition. They'd like me to find the limit. So first things first, I'd like to take the limit as x approaches negative 1 of just the denominator. Let's just look at the denominator. That's 3 times x plus 1 squared. Basically, anytime they give me a fractional limit, especially in a free response question, I am very, very suspicious, maybe, that this is going to be a L'Hopital's rule question. And so when I put this in the denominator, I see that I get a 0 down there, and now I'm even more suspicious. I know that the denominator is 0. Now let me check to see if the numerator's limit is 0. What's the limit as x approaches negative 1 of g of x minus 2? Well, let's see. G as it approaches negative 1 becomes 2. 2 minus 2 is 0. Oh my gosh, I got both a 0 in the numerator and the denominator. The world feels like it's coming to an end, but alas, L'Hopital is here to save me. Okay, so L'Hopital said so. So that means I can use L'Hopital's rule. Okay, and when I do that, I'm going to kind of come over here for this. And that means I get to take the derivative of the numerator. So the limit as x approaches negative 1. the derivative of this is g prime of x, and the derivative of the denominator is going to be 6 times x plus 1. Okay, I notice again that the limit as x approaches negative 1 of the denominator is 0. So again, I'm very suspicious. I'm like, oh man, what's going on here? They're trying to get me again, you know? Let me do this to the numerator again. What's the limit as x approaches negative 1 of g prime of x? So that's the derivative of y. That is dy dx. Well, they know that at that point I have the point negative 1, 2. What I need to know is at negative 1, 2, what is dy dx? Well, dy dx, if I go up here and look, if I square negative 1, I get 1. If I half 2, I get 1. 1 minus 1 would be 0. So again, I get 0. Oh my gosh, I have to use L'Hopital's rule again. So now that I'm using it a second time, I'm going to take the derivative again. The limit as x approaches negative 1 of g double prime of x all over 6. Now this time I don't use the first derivative to calculate this thing at negative 1, and I realize the denominator can't be 0, so no more L'Hopital's rule. I am going to get some sort of answer as long as this thing is defined, as long as g prime double prime of x is defined at negative 1. And g double prime of x is the second derivative. So I'm going to put the second derivative in here at negative 1, 2. So when I put that in, I'll get, here I'll have negative 2 minus 1/2 of 1 minus 1. So basically what I end up with is negative 2 over 6, which is negative 1/3. And I have done it. I have found my limit. Last problem in here says I've got this h that is the particular solution where h naught is equal to 2. And they want me to use Euler's method starting at 0 using 2 steps to approximate h of 1. So what I'm starting with is some x and some y. I've got an equation for dy dx. I'm going to use that to write a tangent line. And then I'm going to do a little bit of work to kind of approximate this thing for the next line, and we're going to keep on going about our business. Euler's method is just repeated use of tangent lines to approximate something. We're starting off at 0, we want to end at 1, and I want to do this twice, so I'm going to have one step in the middle. The step in the middle would be at a half. My y value to begin with is 2. And so the very first thing I want to do, and I'm going to rewrite what dy dx is because I think that's going to be important for us. Dy dx is x squared minus 1/2 y. So just so we can remember. So to find that, I'm going to put 2 in for y, 0 in for x, and I get negative 1 when I do that in my head real quick. So this means my tangent line is going to be equal to y is equal to 2 minus 1 times x minus 0. I know that x minus 0 part may feel a little strange to you, like maybe unnecessary, but I kind of think it's important to go ahead and write this as a full tangent line just so we can kind of make sure we get into the habit of doing that when it gets more complicated. And then to approximate the next thing, what I'm really trying to approximate is my next y value. So to approximate my next y value, I need to put in my next x value into this tangent line. So basically what I end up with is 2 minus 1 times a half. Well, 2 minus a half is 1.5 or 3/2. So next I want to find my dy dx. When I do that, I'm putting in my x of 1/2, which is 1/4, minus 1/2 times 3/2. So I've got 1/4 minus 3/4, which gives me negative 2/4 or negative 1/2. So I have y is equal to 3/2 minus 1/2 times x minus a half. I'm going to put 1 in for x now. It's going to be 3/2 minus 1/2 times a half. Or basically what I end up with is 3/2 minus 1/4, which is 6/4 minus a fourth. So my answer is 5/4. 5/4. So basically I'll say h of 1 is approximately 5/4. This is Euler's method. It is a thing that could be on the exam. But also, L'Hopital's rule is something I would not rule out them putting on the exam. I know that they're going to try to hit to mostly things that are BC only topics, but this has only been a part of the AB curriculum in recent times in the last maybe 3 years. So maybe this is year 4 now. I can't remember exactly. All right, now we're back to an AB problem. So here, problem 5 is dealing with this funnel. I remember when this was a problem. I think some of our AB kids got a little scared of this problem. We've got the inside of a funnel. It's got a height of 10 inches. It's got circular cross sections all the way down. They want me to find the average value of radius. So they've given me a function for radius in terms of height. So to do this, to find the average value of it, remember it's 1 over b minus a, the integral from a to b of f of x dx. That tells me the average value of f from a to b. Okay, so to do this, what I need to do is say 1 over 10 minus 0, the interval that I'm given, the whole funnel, integrate from 0 to 10 of r of h dh. So this is basically 1/10, the integral from 0 to 10 of 1/20th times 3 plus h squared dh. I'm going to bring that 20 out, so that's 1 over 200. And when I integrate this thing, I'm going to end up with 3h plus 1/3 h cubed. And I'm going to evaluate this thing from 0 to 10. So I'm going to end up with this 1 over 200 times 30 plus 1,000 over 3. And I'm going to say that this is in inches. I am not simplifying that. If you feel like simplifying that, that's your own prerogative. I'm walking away. Find the volume. Okay, this is just kind of, in a way, if you imagine this to be the function right here, right? We're going to spin it around, and when we do that, we're going to make these little discs, right? These little discs everywhere we spin, and these little discs will have really small heights. I know the radius, and we'll sum them all up. To do that, we're going to integrate this thing. The radius, pi r squared, is the area. So basically I need to integrate the area times the width. So the area is pi, the radius function squared, from 0 to 10 dh. The radius function is 1/20th, 3 plus h squared. When I square all that, or 3 plus h squared, excuse me. Let me kind of come in here and fix that. That got a little wild. Okay, I'm going to go ahead and square that 1/20th. That gives me 1 over 400. So I got pi over 400 on the outside. And I'm going to square the 3 plus h squared before I integrate. That gives me 9 plus 6h plus h to the 4th. When I integrate this, I have my pi over 400 times 9h plus 3h squared plus h to the 5th over 5 from 0 to 10. So this tells me that it's pi over 400 times 90 plus 300 plus 1 with 5 zeros, so 100,000 over 5. And what are we going to say this is in? Inches cubed. Again, you can simplify if you'd like. The funnel contains some liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second at this instant. So you know what this sounds like to me, guys? Sounds like related rates. So what are we trying to find here? Well, we're trying to find the rate of change of the height. When are we trying to find it? We're trying to find it when the height is 3. And what's something that I was given about this that can kind of help me solve it? I was given that dr dt is equal to 1/5 inch per second. They gave me an equation for r. It was 1/20th times 3 plus h squared. So when I take the derivative of that with respect to time, that gives me dr dt is equal to 1/20th times 2h dh dt. Put in what you know, solve for what you don't. I know h, I know dh, or I know dr dt, and I'd like to solve for dh dt. So I have, multiply the 20 on the other side, 20 times 1/5 is equal to 2 times the 3, which is 6 dh dt. 20 divided by 5 is 4. So basically I have 4/6 is dh dt. That is going to be in inches per second, and we have finished problem 5. Problem 6 is a question about series. The series information is limited on this exam, but it's still worth going through so that you can make sure you're familiar with it. They've given me this a Taylor series about 1 is going to converge to some function f of x for all of its x in its interval of convergence. They tell me what f of 1 is, they tell me what f prime of 1 is, and then they give me a formula for finding the other derivatives at 1. They want me to write the first 4 non-zero terms. To do that, I'm going to need a couple more derivatives. I already have 2 places, so I can already know that the Taylor series is going to start by saying 1 minus 1/2 x minus 1. But to get the other terms, I'm going to need the second derivative at 1. So I'm going to put that into here, and that's going to give me basically a half. I would need to find the third derivative of 1. So that's going to give me negative 2 factorial over 8. So negative 1/4. Oh wait, I might have made a mistake here. I did. I forgot to square the 2, so it's 1/4. Okay, so I have 1/4 plus, so 1/4 over 2 factorial x minus 1 squared plus negative 1/4 over 3 factorial x minus 1 cubed plus dot dot dot. Those are my first 4 terms, and now they want the general term as well. The general term just means the formula for finding the derivative, negative 1 to the n minus 1 factorial over 2 to the n, all divided by n factorial times x minus 1 to the nth power. If you remember, it's the nth derivative at a over n factorial times x minus a to the nth power. That is the general term. This is the way we find terms in a Taylor series. So then plus dot dot dot. All right, I would like to find the interval of convergence. They've told me that this thing has a radius of convergence of 2. Since they've told me that, what I know is, I already know that this thing is centered at 1. So that means I can go 2 in either direction, and I don't know about the endpoints, but everywhere in between that range is good. So I know going all the way up to 3 and going all the way down to negative 1 is okay. What I need to care about happening is what happens when I sum up this thing at, so like when x is equal to 3. So when x is equal to 3, I'll have the series, and I take the general term, and I'm going to put 3 in for x. Negative 1 to the n, right? 3 minus 1 factorial, 2, excuse me, not 3 minus 1, n minus 1 factorial, 2 to the n n factorial, and then I have 3 minus 1 to the n, or 2 to the n. Those 2 to the n's go away, right? They'll simplify out, they'll kind of reduce. This reduces into just n, so what do I end up with is the series from -1 to n over n. This converges. It's the alternating harmonic. But what about when x is equal to -1? Well, that will mean that I'll have the summation of -1 to the n. That n minus 1 factorial over n factorial will still reduce to an n. There's still a 2 to the n in the denominator. And now in the numerator, what we have, instead of a 2 to the n, is a -1 minus 1 to the n, or a -2 to the n. -2 to the n is 2 to the n times -1 to the n. So basically what I end up with is a summation of -1 to the n times a -1 to the n. There's a 2 to the n still in there as well, 2 to the n in the denominator. Basically what we end up with is -1 to the 2n over n, which is just the summation of 1 over n. This diverges. It's the harmonic series. So its interval of convergence then would be not including -1, but it does include 3. There's our IOC. Okay, they want us to approximate f at 1.2. To do that, I'm going to put in 1.2 in for x, only using the first 3 non-zero terms. If I do that, that means I'm going all the way up to the squared term. So I have 1 minus 1/2 of 0.2, that's 1.2 minus 1, plus 1/4 over 2, 0.2 squared. I am not simplifying that. Somebody else can. All right. Show that the approximation is within 1/1000th of the exact value. Guys, what kind of series is this again? It's an alternating series. An alternating series have an alternating series error bound. To find the amount of error, we look at the next term up. Our next term up would be our cubic term. So I know that my error, right, is less than or equal to, all right, it's less than or equal to the next term, which is the 1/4 over 3 factorial, and then I have 1/5, 0.2, to the third power. So this is 1/24, and 5 cubed is 125. I know for a fact that that is less than 1/1000th. And therefore, we have done it. We have solved the last part. And congratulations, you did all 4 non-calculator free response questions in 33 minutes instead of the given hour that you're given by the AP exam. All right, guys. Well, this was fun. I hope you're all doing well. Again, if you have questions, comments, things you need to see, things you didn't understand, please make sure you let me know. I'd be happy to get back to you and help you in your journey, guys. Take care.